Welcome back. In this lesson, our a value is not equal to 1. All right, so if a is not 1, we're going to divide all terms by a. All right, so that means, and always do this first. Reason is that way you won't forget, because if you forget, it's going to be a problem. Everything else is going to be wrong. Oops, I don't like spinning ball of death. I didn't make a line. Well, let's see if we can get a line under all of them. There we go. All right, so we're dividing everything by -1 because our a is equal to -1. Even the 0. So it won't change, but that's okay. All right, so it has to be divided by -1. All right, so negative x squared divided by -1 is x squared. 5x divided by -1 is -5x. 2 divided by negative 2 divided by -1 is a positive 2 equals 0. If we had subtracted the 2, added 2 to both sides, right, it would have been 2, and then we would have divided by -1, and it would be -2, and that's what's going to happen to it when we subtract 2 from both sides. All right, but do that divide by -1 first, just so you don't forget. Our next step is to isolate the constant, so we're going to subtract 2 from both sides. We have x squared minus 5x equals a -2. All right, now we're going to add b, which is -5, divided by 2, squared to both sides. You're going to keep it as a fraction. All right, you saw how easy they are to square, all right, and how much easier it is to take the square root and simplify those square roots. And if you have decimals, it's a nightmare, and none of your answers should have any decimals in it. They won't have decimals on a multiple choice question. Do not change them to decimals. Just leave them as fractions. Perfectly nice. Equals -2 and then plus -5 divided by 2 squared. All right, so x squared minus 5x, we're just going to square the -5 and square the square the 2. So that's going to be plus -5 squared is going to be positive 25, and 2 squared is 4, equals -2 plus 25 fourths. Now we'll factor. It's always going to be x, whatever that sign is, it's a minus, subtraction, and then half of b. b is 5, so 5 divided by 2 squared, because there's 2 of them, right? It's a perfect square. We've guaranteed it by adding b divided by 2 squared to both sides. Equals, all right, we've got to change that, so it has a, I don't know why I put 4 there. 8 there. It was supposed to be a 4. We need to have a denominator of 4, so we can add that to the 25 fourths. All right, so -2 times 4 is -8. So I was thinking of what the numerator was going to be, but I was writing the denominator. All right, so we have x minus 5 halves squared. We'll add those together. That's going to be a 17 fourths. We'll take a square root of both sides. X minus 5 halves all squared equals plus or minus square root of 17 divided by the square root of 4. And then we just have to simplify it. So we have x minus 5 halves, because the square and square root cancel, equals plus or minus square root of 17, can't do anything about that, and the square root of 4 is 2. So now we'll add 5 halves to both sides. X equals, that's interesting, my equal sign there looks kind of funky. 5 halves, because we added 5 halves, so now it's going to be positive, plus or minus square root of 17 halves. Let me fix that. 17 looked like an N. And there we go. There's our answer, right? Our answers, there's 2 of them. X equals 5 halves plus square root of 17 halves, and x equals 5 halves minus the square root of 17 halves. All right, that's all there was to it. We just have one extra step. Let's take a look at, coming up any day now. We got this one. All right. Divide all terms by a first. Don't do anything else until you do that. A here is 2. It's our coefficient in front of x squared. So we're just going to divide everybody by 2. That gives us x squared equals a -6x minus 13. I do need to move the x term over and we'll leave the constant there because we want to isolate c. So we'll add 6x to both sides. So we have x squared plus 6x equals negative 13. Now we'll add b, which is 6, divided by 2 squared to both sides. That's going to be x squared plus 6x plus 6 divided by 2 is 3. 3 squared is 9. So we have negative 13 plus 9. On the left, we can factor that as x plus, because that's a plus, half of 6 is 3. Right, and that would be x plus 3 times x plus 3, or x plus 3 squared, equals negative 13 plus 9 is a negative 4. And then we take the square root of both sides, so we have x plus 3 squared equals plus or minus the square root of negative 4. Square and square root cancel, so we have x plus 3 equals negative 4 is a perfect square. It's plus or minus 2i. And now all we have to do is subtract 3 from both sides, so we have x equals negative 3 plus or minus 2i. Don't combine them. They're not like terms. One's got an I and one doesn't. That's all there is to that one. Right? So we just had to divide both sides by 2 first. Right? We made sure that the x terms were on the one side, constants on the other, and then we just used our steps for our steps for completing the square. And so here we have this one. All right. So our first step is to divide everybody. So by the way, our last problem there, we had so the very first problem, it doesn't say it, but we had a complex solution. It was irrational because we have a radical there, but that is real. Now on the second one, we had a complex solution. It was a perfect square. We had an I, but it was a perfect square. On this one, we're going to have an irrational solution. It'll be real, but it'll be irrational. So we're going to divide everything by 4 because a is equal to 4. That's going to give us x squared plus 8x minus 3/4 equals 0. Add 3/4 to both sides and do leave that as a fraction. So we have x squared plus 8x equals 3/4. We're going to add b, which is 8, divided by 2 squared to both sides. Alright, so it's going to be x squared plus 8x plus 8 divided by 2 is 4, and 4 squared is 16. On the left, we can factor that to x plus half of b, and half of b is 4 squared. And then I should put that over here, just to remind you that it's always x plus or minus b divided by 2. I should put that on the last page too. Did I? Nope. And that one had it. All right, so continuing on, equals 3/4 plus, want to change 16 to fourths. All right, so we just have to multiply 16 by 4, so that'd be 64/4. So we have x plus 4 all squared equals 67/4. Take a square root of both sides. Don't forget plus or minus on the number side, and split that that fraction into 2 radicals. All right, so I think I'm going to go this way. I'm running out of space going down. So square root of x plus 4 squared is x plus 4. And then we have equals plus or minus 67 is a prime number. That's not going to, can't simplify that at all. And square root of 4 is 2. And now we'll just subtract 4 from both sides. So we have x. My ears keep popping, so it's hard for me to hear myself talk. It's really annoying. So we have x equals negative 4 plus or minus the square root of 67. divided by 2, and there we're done. Sometime, now I am perfectly fine with that answer, perfectly good answer. However, sometimes you might be taking a multiple choice test, and they may rewrite that. They want it to be one fraction. Notice that that -4 does not have a denominator. So if we want it to have a denominator of 2, what are we going to have to do to the -4? Right? Well, if we still want it to be equal to -4, we're going to have to multiply the -2 by 2 and make it -8. So notice -8 divided by 2, that's still 4. So we could write this as -8 plus or minus the square root of 67, all divided by 2. Do not feel, though, however, that you need to change your answer to that one. But I do want you to be able to recognize that those are equivalent to one another, right? And so if you're taking a multiple choice test and the answer choice is -8 plus or minus the square root of 67 divided by 2, I don't want you to go, my answer is not there. Because it is there, it's just written differently. Oh, I hate coughing when I'm talking. Let's look at the next one. Actually, I want to look at two more. Let's see if I can get my coughing under control in the last two problems. All right, so I made this as interesting as I could by giving myself an A term of 7. So that's not a pretty A term. Just not going to be pretty when we divide by 7. Lots of fractions here. Just to show you that even if you end up with a lot of fractions, it's not that bad. All right, so I'm doing a worse problem that I'm going to give you. All right, so we're going to divide everything by 7. All right, so that's going to give us x squared minus 6/7 x, can't do anything there, and plus 15/7. And if you were to try to change those to decimals, you would have irrational numbers. They just keep on going on and on, repeating. Well, they wouldn't be irrational, but they would keep repeating. And so you wouldn't have an exact answer because you would either truncate it or round it, and that would not be good, equals 0. So you've got to keep those as fractions. Always keep them as fractions when you're working, pretty much always, but definitely when you're working with completing the square. All right, so now we have x squared, sorry, we're going to subtract 15/7 from both sides. All right, so minus 15/7. All right, so that gives us x squared minus 6/7 x equals negative 15/7. All right, and now we're going to add b divided by 2 squared to both sides. X squared minus 6/7 x. And you might think, what do I do? How do I get half of 6/7? All right, well, I have it right over here for you. All right, so half of negative 6/7 means I'm going to divide it by 2. So negative 6/7 divided by 2 is the same thing as negative 6/7 times a half. So that would have been negative 6 over 14 squared. But we can reduce that. So negative 6 over 14, that reduces to negative 3 divided by 7 squared. All right, so since I have a 3 in the numerator there, a 6 in the numerator there, half of 6 is going to be 3. So half of 6/7 is 3/7. And we have to add the same thing to both sides. So negative 15/7 plus negative 3/7 squared. That gives us x squared minus 6/7 x plus, now we'll just square them, so 9/49. All right, so lots of fractions here, but it's not going to be any problem. Right? They follow a pattern. They're not that difficult to work with. Negative 15/7 plus 9/49. On the left-hand side, we could factor that. X minus half of 6/7. It was the thing we squared, right? When we divided 6/7 by 2, it was 3/7. So it's going to be x minus 3/7 squared equals, we need to change the 15/7 so it has a denominator of 49, right? So I have to multiply the numerator and denominator, right? Oh, I didn't write that over here. X plus or minus b divided by 2 squared. We have to multiply the numerator and denominator by 7, right? So we would have, so 15/7 here is equal to, multiply 7 by 7, you get 49, and 15 by 7, you're going to get 135. Right? Yes. I'm doubting myself. Hold on. Oops, no, wait. Right idea. Except it's not 35 times plus 100, it's 35 times plus 70, right? 7 times 10 is 70, and 7 times 5 is 35. So 70 plus 35 is 105. Had the right idea, I added it to 100 for some reason instead of 70. So 105 49ths plus 9 49ths. That's going to give us, so we have x minus 3/7 all squared equals, it's going to give us 114 49ths. I'm going to just kind of move over this way. All right, so we're going to take square root of both sides. I really should have just wrote smaller and I'd be fine. X minus 3/7 squared equals plus or minus square root of 114 divided by square root of 49, and moving right along. I probably have to move up soon if I'm going to really run out of space. So we have x minus 3/7. Kind of cramming it here. Let's see if I can give myself just a little bit of space. They're all stuck together. I can move that over just a wee bit. All right, so that would be x minus 3/7 equals plus or minus, so 114. All right, so it's divisible by 2. So that would be 5 and then 7, and that's a prime number. So can't simplify 114. So we have square root of 114. Add square root of 49 is 7. So we can squeeze it in the last step. Add 3/7 to both sides. X equals 3/7 plus or minus the square root of 114/7. All right, and so we got a, what did I say? Oh, on the top there I say complex solution, not a perfect square. Bum, bum, bum. I dropped my negative. So, guess what? Sorry. If I wasn't already 18 minutes in, maybe I'd redo this. But we just have to change a few little things. We had a boo-boo. Hey, at least I wrote the words complex solution above, and I caught my boo-boo. So be careful. If you're figuring stuff out, it's easy to drop a negative. All right? Just try to look back, especially if it's a, like a test or something, or benchmark, and look back and say, does everything look good? Because if I looked back, I would say, uh-oh, my negative disappeared. All right, so now we have a negative 105 plus 9. We're going to subtract because they're not this, they're different signs. So that's going to be negative 96 49ths. So now we're going to take a square root of both sides equals plus or minus, and I'm going to split that negative, square root of negative 96 over the square root of 49. All right, so now let's see if 96 simplifies. And matter of fact, I know it does because it's 100 minus 4. And 100 is divisible by 4. So this is going to be divisible by 4. So that's going to be 24. And then we're going to have 4 and 6. So 1 4 comes out, 1 4 goes away. All right, just make sure that's right. 2, yeah, that's right. All right, so new answer here. And of course, 49 is a perfect square. And we see we have a negative. So this is going to be x minus 3/7 equals plus or minus 4. Square root of negative 1 is I. And then we're going to have the 6 left under the radical. Yeah, 6 isn't a prime number, but it's 2 and 3, and so you can't do anything with a 2 and a 3. And that's divided by 7. So final answer, we'll add 3 sevenths to both sides. X equals 3 sevenths plus or minus. And then we have 4i square roots of 6 divided by 7. And we're done. That's it with this problem. Let's do one more problem. We could do it. All right. We're going to have a real and rational solution here. So here we had a complex solution, right? Because we had an I in it, and it wasn't a perfect square because we had a radical left over. We had a irrational solution. It was real. There's no I. We have no square roots of a negative number, right? But we have a radical. So this is going to be rational. What's that mean? All right, well, irrational numbers are numbers that you can't write as a fraction. Rational numbers you can write as a fraction. Let's see what we get here as an answer. Step number 1, we have to divide all terms by a, and our a here is 5. So divide by 5, divide by 5, divide by 5. And then I have x squared equals 6/5 x plus 8/5. Lots more fractions, but it's okay. We have to move the 6/5 to the other side, right, so that we have all the x terms together, and we've isolated the constant. X squared minus 6/5 x equals 8/5. Step number 3, we're going to add b divided by 2 squared to both sides. So that's x squared minus 6/5 x plus, right, so 6/5, half of 6/5 would be 6/5 times 1/2, which would be 3/5, right? If your numerator is an even number, you're just going to take half the numerator and keep the denominator, and you have half as much. Right, so this would be negative 3/5 squared equals 8/5 plus I squeezed it in, negative 3/5 squared. Squeezed it in. Let's see if I can just move everybody over though. Oh, that goes together. All right, so now let's simplify. We have x squared minus 6/5 x plus, that's going to be negative 3 squared is 9, 5 squared is 25, equals 8/5 plus 9/5. And let's factor. All right, so x squared minus 6/5 x plus 9/25. Remember the pattern, it's x plus or minus b divided by 2 squared. And we know what b divided by 2 is, because we divided b by 2 before we squared it. So we have x squared minus half of 6/5 is 3/5 squared equals, and oops, somehow my 9/25 became 9/5. We need a common denominator, so we have to multiply numerator and denominator of 8/5 by 5, right? So that's going to be 40/25 plus 9/25. That gives us x squared minus 3/5 squared equals 49/25. So now we'll take a square root of both sides. So we have square root of x squared minus 3. Oh, what did I do? There's a square. That doesn't belong there. Why did I put a square there? And nobody said anything. You were probably all looking at me at home going, what? Ms. Shagna, there's no square. Kind of like look at that step above it. So x minus 3/5, right? X minus 3/5 times x minus 3/5 give us x squared minus 6/5 x plus 9/25. So this should be x minus 3/5 squared. Okay, equals. All right, now let's continue. So we take square root of x minus 3/5 squared equals plus or minus, and let's split that into 2 radicals, the square root of 49 over the square root of 25. All right, and so square and square root cancel. We have x minus 3/5 equals plus or minus. All right, so we have 49 over square root of 49, that's 7. Square root of 25, that's 5. We have no radicals left. Look at that. Now we're going to add 3/5 to both sides for our step 6. So we have x equals 3/5 plus or minus 7/5. And that is not an acceptable answer because those are things that can be combined together. So combine them. You will not get full credit if you leave it like that. All right, so we have x equals 3/5 plus 7/5. And we have x equals 3/5 minus 7/5. So 3/5 plus 7/5 is going to give us 10/5, which is 2. 3/5 minus 7/5 is going to be negative 4/5. And there's our answers. If you get rational solutions like this to a, when you complete the square, it means it was factorable. But I want you to practice it anyway. So let's take a look and see that this was indeed factorable. Let me see if I can just copy that. I would probably take more time to, there we go. And then, come on. When I want a copy box to come up, when I want a copy box not to come up, it comes up all the time. Oh, I'll just rewrite it on this page. All right, so let's, oh, I see spinning ball of death there. Here we go. I wasn't quick enough. That's all right. Well, I think I remember 5x squared equals 6x plus 8. I'll put a page in. Here we go. All right, so 5x squared equals 6x plus 8. All right, so now we're going to solve by factoring. Probably should have, sorry about that. I probably should have broken this up into 2 podcasts, but that's all right. This won't take us too long. We're going to subtract 6x and negative 8 from both sides so that we have everything on one side. 5x squared minus 6x minus 8 equals 0. So 5 times negative 8 equals negative 40. So we need 2 numbers that multiply to get, what did I do? I don't want to write that down. Ignore that. I meant to write 5 times negative 8, not like that, equals negative 40, and b is negative 6. So we need 2 numbers that multiply to give us negative 40. They are not 5 and 8, and add to give us negative 6, but they are negative 10 and not 2, 4 is what I meant to write. Sometimes my hand isn't listening to my brain. My brain was saying it's negative 10 times 4, that equals negative 40, and negative 10 plus 4, that equals negative 6. So now we have 5x squared minus 10x, you become a group, plus 4x minus 8 equals 0. Greatest common factor is 5x. If we divide by 5x, we have x minus 2. Greatest common factor is 4. If we divide by 4, we have x minus 2. We can factor out that repeating x minus 2, and we'd be left with 5x plus 4, the things x minus 2 was multiplied by. And now we'll set that equal to 0 and solve. X minus 2 equals 0, and 5x plus 4 equals 0. Add 2 to both sides, x is 2. Subtract 4 from both sides, so 5x is negative 4, and then divide both sides by 5, so x is negative 4/5. Now look at our answers here. X equals 2 and x equals negative 4/5. X equals 2 and x equals negative 4/5. Now, this here, completing the square, was a lot of work for two rational solutions that I could have factored. In a later lesson, not the next one, we're going to learn how to tell if something's factorable. So you don't use a more complicated method, even though this wasn't, we just followed the steps. But there's more of them. A more complicated method when you could have used an easier method, all right? So anyway, thanks for watching the podcast, and see you in the next podcast. Bye for now.